All right, so the answers are 1140 for number 1 and 2,598,960 for number 2. Okay, so the big question is then, how do you know when to do permutations and how do you need to know when to do combinations? Just basically ask yourself, does the order matter? So what I'm asking is, how are you going to know when you need to divide? There's 2 times when we've divided. One is when you've got repeating items of the same thing, right? Like when we had that quarter problem. If we had more than 1 quarter, then that's something we keep in mind. Another time when we've divided is when we don't care about how the things are arranged. We're just looking at a group of things, like 5 cards out of a deck of 52. It doesn't matter what order I have them in my hand. I've just got those 5 cards, right? So those are times when you're going to divide out the order. That's a combination. Otherwise, it's just a permutation, and you don't do any division. Okay, up here I have 3 random problems. I'm not going to tell you when to divide and when not to divide. I want you guys to discuss when you would divide and when not, and then go ahead and see if you can figure out the answers.
Obviously it's right.
All right, guys, there's your 3 answers. You're going to go through the process of finding out how many ways this thing can happen, then asking yourselves, do I need to divide out the arrangements? So let's go ahead and do this. Jesse, how many groups of 5 kids are possible in a class of 30? So how many choices do I have to make here? I've got to make 5. How many options do I have for the first choice? 30. Then 29, right? So on and so forth. You lose a kid every time you call them up. You can't call them up twice. For the same round anyway. And then it says 5 kids are possible, right? So that's pretty much it. But this is the next important question. Does the order matter on this problem? Does it matter what order I'm calling these kids up in? Does it say I need to do it in a special order? Is it just saying I've got a group of 5 kids? Okay, so it's just saying there's a group. So I need to factor out the order. I need to divide out the order. How many kids are there? 5. How many ways can you arrange 5 things? If you do your math there, you should get 142,506. So we're going to go through the same process here, guys. Listen to the questions I'm asking myself. How many choices do I have to make is the first question. So Bendito, how many choices do I have to make for this? You got to make 6. Which one's going to come first? 5th, 4th, 3rd, 2nd, and last. And so how many choices do I have for my first letter in my name? 6, followed by 5. Because you can't repeat a letter. If I'm arranging these letters, I can't put the same letter in 2 different spots, right? 4, 3, 2, 1. My name is Bailey, right? So there's 6 letters in that arrangement. Now, here's a question. After you got, did you guys catch there's 2 questions? How many choices do I have to make? And how many options do I have for each choice? There's my 2 questions. Now we've got a 3rd question. It's our new question of the day. Do I need to divide out some kind of order? And I told you there's 2 times you do. Do I need to divide out some kind of order here?
No, because it says arrange, and we don't care.
First of all, it says arrange, which means when we're talking about the order, then we're not going to divide the order out. We want the order, so don't divide it out. Second, the other time, though, is when you have a repeating letter. Do I have a repeating letter in my name? No. So once again, that's another reason I'm not going to divide on this problem. The answer is just 6 times 5, 4, 3, 2, 1 gives us 720. Now, if I used a different last name in here, okay, so Alexis has 2 I's in her last name, then you would have to divide something out. You'd have to divide out the arrangements of those 2 I's, 2 times 1. All right? So let's go ahead and take a look at number 3 here. Okay, now pay attention to those 3 questions, the same 3 questions. How many choices? How many ways for each choice? Do I need to divide? Here we go. Tia, how many outcomes are possible for first place in a triathlon if there's 10 competitors? First of all, how many choices do I have to make here? You have to make 1 because we're looking who's coming in first. That's it. I have to make 1 choice. Now, boom, there's one choice. Now, the second question, how many ways can I make that choice? There could be 10 possible outcomes. Now, when we're looking at a race, first place, does the order matter? In a race, the order does matter. First, second, and third place are very special orders. So we don't need to divide on this problem. The answer is 10. And also, you could just read the problem and, well, of course there's 10. How many outcomes are possible for first place in a triathlon if there's 10 competitors? Well, there's 10 people, so it could be anybody 10, right? So, anyway, that's it for the day.